Thank you. So up next is Alex Gaynor. He's going to talk about scaling Django, serving traffic, and growing your team. Alex is a software engineer from RDO in San Francisco. Alex, thank you very much.
More resources. So a website would be said to be scalable if you could if adding n more servers let you handle n times more traffic than one server, or at least n times more. A project itself could be said to be scalable if adding more engineers lets you move faster than adding a single engineer. And so that's really the thing I'm interested in tackling is how do we make it so that we really can get putting more engineers onto a project really can let you be more effective and actually let you get the benefits of having more people working on your project. So there's a line which I think is from a book called The Mythical Man Month. It says 9 women can't have a baby in 1 month. And my response to this is always, but 9 women can have a baby in 1 amortized month. So yes, we know that there are limits. You know, at a certain point, tasks can't be broken down into smaller bits. And so we have to have projects that, certain projects, you can't just throw more resources at them. Not every project can be solved that way. But given a large enough project, it should be able to be divided into pieces that let lots and lots of people work on it. And that's sort of, I think, an ideal. So that is a good book. I still recommend The Mythical Man Month. You should still read it. But so most of this talk is going to be about how you scale a project and a team, because a project is a bunch of code and it doesn't really do anything by itself. You need team. You need software is written by people. People make software. So the first thing is the idea of the bus factor, which is how many people would need to get hit by a bus at one time before a part of your project would have no one who knows how it works. And so sort of intuitively, a bus factor is the inverse of scaling. If you have a bus factor of 1, your project has not scaled very well, because only one person understands how a system works, only one person can make changes. That's the opposite we want. Our goal is to have a giant bus factor, so big that no bus could possibly hit all those people at once. So I think the first step of that is having one-click deployment. So the idea is shipping your software should not be something that only one person can do. Being able to take the code from your Git repository, from your Mercurial repository, from your Subversion repository, and turning that into a finished product, whether that's a tarball you give your customers, a binary you ship out, or deploying your website onto your servers, that should be a process anyone should be able to do, and it should be totally repeatable and totally automated. So tool I'm a fan of for doing this is Fabric, awesome Python tool. And I think the goals you want to target by doing something like this are you should be able to deploy any revision from your project at any time. Whenever you decide to, you should be able to put a revision live, and at any time you should be able to roll back to any previous version. I think these are really simple goals that, unfortunately, until recently, a lot of people really didn't embrace. I know until a few years ago, anytime I wanted to redeploy my software is, okay, let me manually SSH into my server, git pull, okay, now I have to do something to restart Apache. I don't remember what. Go through history and grep through and see if I can find it. And the problem with this is it tends to break things, and it relies on sort of secret knowledge. Whoever set the system up originally is basically the only person who knows how it works. The advantage of any sort of having a one-click system is, first of all, you get the advantage of having one click. One click is obviously easier than 30. But also, to have any sort of one-click automated system, you have to take the time to write out code to do it. And I think that's a really important step. The step of turning this knowledge that one person has into code instantly makes it transferable to anyone else who works on your project. Because code is a language that we can all speak. It's something that every developer on your project shares by definition. So if you have it in this form, it's now available and accessible to everyone on your team. So a related piece of idea that has gotten really more popular lately is the idea of one-click infrastructure. So we started with here is a server, let me put my code on it. The idea of one-click infrastructure is that you should be able to, at any point, not just put your code on a server, but get a whole new server. We've been, I think, really blessed by this, the rise of the cloud, which, whatever its faults, really does give us the opportunity to anyone on demand can have new infrastructure available to them as they want it. And so I think this is really just taking the idea further, because you could put your code on the server, and it was really great that you had an automated process for that. But what was actually running on the server? Well, I remember I installed it, and I think I was using this version of Debian, and I put some stuff in cron. I don't really remember what that was. You're migrating to a new server. Okay, what are all the things I need to copy over? I think probably most people have been there trying to migrate pieces of infrastructure, and this is another place where the more we automate, the more we put into code, sort of the less secret knowledge individuals have. It's not whoever originally set this up now has special knowledge. It's anyone who can look at this piece of code now has access to this knowledge on our team. And I think that's a really empowering thing. I don't really consider myself to be a system administrator. I really hate having to work with servers. But I really like the fact that the knowledge of how our servers are set up is not limited to whichever member of my team set it up. It's available to all of us. We can all understand what's going on. Unfortunately, the tooling in Python yet is not great. So 2 of the projects I'm mentioning, Chef and Puppet, are Ruby projects. Salt is a Python project that looks like it's going to be pretty cool in the space. I know Armin Ronecker, who is in the room somewhere, is a big fan of it. Hopefully he will be able to tell me about its merits and why it's totally awesome. So those are, I think, really 2 pieces of infrastructure you need to have on your team to start going forward, and with making it available, making everything sort of easy for new developers. The other part of it is, what do you do once you actually have a new developer to make working with your project really available and accessible to them? So first step is, this is what I think setting up every single Python project everywhere should start. You should check out your repository. I just happen to write Git there. Really, any version control system will happily work. You should be using virtual env, which are pretty much the best idea ever. The idea of a virtual env, for those who aren't familiar with it yet, is basically take every dependency your project could have, every piece of Python that you're running, and isolate it from the system. So in one virtual env, you can have a Python package at version 1, and another virtual env, you can have a Python package at version 2, and these don't interfere with each other at all. Every dependency you have is totally isolated into this virtual env, and you can switch between them really, really easily. So then you should be installing your requirements. I think a requirements is sort of another level of this. You can document exactly what your project requires. It's no longer sort of whatever happens to be installed on your system. It's another layer of documenting as code what exactly the entire environment should be. What should everything look like to run this project? And the last thing is actually not an idea I've tested in the real world yet, using this program called Supervisor D. So, sort of a brief interlude. This was my experience when I started developing for the web about 5 years ago. You need basically 2 things I found. You needed to have an HTTP server, which is really easy. In Django, you did python manage.py run server, and you got an HTTP server, and that was really easy. And you probably needed a database, and mostly your operating system kept that running at all times. At least it always did for me. So those were about the things I needed 5 years ago to get running. Here are the things I found I've needed to get projects running today. I need an HTTP server. I need databases, plural, because one wasn't good enough. I've got queues that worker processes that are handling a queue. I've got a bunch of custom daemons for my project, and tons of other stuff. So I found the number of processes has really exploded. The number of things you need to have running just to get your project started. So Supervisor D is a really cool Python package that basically takes a configuration file and runs all the processes in it. So it gives you a single basically process that monitors and makes sure your HTTP server is running. And if it stops running, it can be configured to automatically restart it, to log errors, and sort of handle all the things about running a bunch of processes at once. So it's a really, really cool idea for production on your actual web servers to be able to start and stop processes in a way that's really generic to what you're doing, regardless of how the process works. You can always start and stop it from the same API. But I think it's possibly a really, really cool idea for development. So instead of the onboarding process being, okay, you start the run process, and then you have to start the worker process, and then you have to start the daemons, and you have to do this all in the right order, or you'll start getting weird errors. Instead, we can automate that. We can put that all in code and have it be a single entry point, which is, again, because it's code and configuration, is inspectable by every member of your team, and everyone can understand what's going on. And it's also just a lot easier for a new developer to have this single command that's uniform across every project than having to learn how each individual project works. I think it's a much smoother onboarding process. Another process which I think is super important and not well appreciated enough is automated testing. When I first really started to be sold on the idea of automated testing, basically my thought process was, how do I verify that I don't ship bugs in my software? And I think for software we've worked on for a long time, you have an intuition about what can break when you make a certain change. I know if I make a change here, I need to watch out because this thing actually also uses that. And I know that last time I was playing with this function, it broke this other thing, so I got to watch out for that. As we worked with a project for a really long time, we get a sense of how different pieces are related. And so we can manually test things pretty effectively. We understand that I know touching this code affects these 3 other things, I'll test them by hand, and everything will be good. The problem is, when you introduce a new developer to your team, they have none of this intuition. Especially for a large project, they have no idea that changing this function also is used implicitly by that thing over there. They don't have this knowledge, so they can't manually test effectively. Even if manual testing can work for your project in general, it will never work for a new developer, I don't think, because they don't have a sense of what can break. So I think automated testing, in addition to all of its other virtues, which I think are many, is that automated testing is much better for a new developer on a project because they don't have to have some sort of secret knowledge about what's expected to break with certain things. They don't need to know the secret knowledge about how different pieces are related because, again, it's all in code. They can see it, and it can automatically be verified for them that their changes are more or less correct. And I think the other part of it is automated testing changes how you write software. The ideal of automated testing is that each piece of your software, in whatever granularity that is, each piece is something that can be executed independently and has results that can be verified. I think this is, in practice, if you just start writing a code base, this is not an entirely natural thing to really divide your code up into lots of small pieces that each have individual responsibilities and that interoperate really well. That's not natural. When we just sit down to start writing code, oftentimes we end up with something a lot messier, lots of pieces that are interconnected in subtle ways, and things like that. But if you're trying to automated test it and really trying to stick to this ideal of components that can be sort of run individually, I think you start ending up with a system design that's much cleaner for new developers. It's much easier for someone who's brand new on a project to just learn about piece A. Just need to understand piece A. Okay, now I can learn piece B. Now I can learn C. Then try to learn, okay, I need to understand A, B, and C, and know that B and C are connected in these ways, and A and C are connected in these ways. It's really hard to try to learn everything about a project at once. But if you can learn piece by piece, it's much more approachable. So this is another practice which I've been very, very fortunate to find at my company is the idea of code review. And I was not totally sold on really rigorous code review until I got started with at my current company. So there's lots and lots of good systems for that. RightVeld is an open source thing from Google. GitHub has its pull requests code review thing. Fabricator is a kind of cool open source project that lets you do code reviews and ticket tracking and a bunch of other stuff. I think Bitbucket is going to be adding sort of code review stuff into their pull review things. But so there's a lot of good tools for this. Really, I think the most important point is that for any of these tools is they let you sort of give comments to a developer about code before it's actually committed to your repository. So I think the most important thing about this is that every single patch should be code reviewed, no matter if it's written by the most senior developer who's in charge of the whole team or the guy who just started. Every single patch should be code reviewed. And I think just sort of intuitively, this really helps defeat the bust factor. If someone else has to look over your code and say, yes, okay, this is good, before it's allowed to go in, someone else has to understand it. You've instantly now doubled your bust factor. It's not possible for only one person to understand. At very minimum, 2 people have to understand. And so I think it's really it's great that obviously a new developer, you want to make sure they don't have all this intuition. You want to make sure their code is good. You have experienced developers review new developers' code. I don't think that's a particularly new idea. It's just sort of obvious. As you're getting started, you want someone to look over the stuff you do. But I think the other side of that's way more important. Make new developers review experienced developers' code. I think this is super valuable and super underutilized. When a new developer reviews an experienced developer's code, they're going to notice all sorts of things the experienced developer isn't going to notice. They're going to notice weird like naming things or a lack of comments. Really anything about the code that's not really obvious to someone who doesn't necessarily know all the pieces of the code base yet. And that's just trying to understand this code is going to give them a lot of that knowledge and make them more knowledgeable about the code base. But it's also going to, the feedback they're going to give is going to make the code base more approachable going forward, because they're giving feedback as a person who doesn't have all the experience. So the feedback is way more valuable from the perspective of how easily will it be for the next developer to learn this code base. Yeah. And I think perhaps the final point, the most valuable thing you can do to make a code base more approachable is embrace the community. I think we're all really fortunate to have found Python, which is an awesome open source project, and a lot of us probably use a lot of other open source projects written in Python. But embracing the community can also make a project way more approachable to new developers. So usually when you're thinking about writing something for your project versus using an existing package, the thought process is basically, how much time is it going to take me to rewrite this software from scratch? And how much time is it going to take me to learn about this existing package and figure out how to work for my project? I think this math is really, really wrong, because that's the cost to get started. The problem is there's a lot of other costs to software. We know most of the cost of software is going to be in maintenance. If you use an existing piece of software, it means every developer you hire, they already have experience. That's one less thing they need to learn, because they can bring all the knowledge they have about this package with them. They come pre-trained on your software. How awesome is that? You hire someone and they already know about a bunch of your systems because you've embraced the community standards. Another part of this is maintaining high code quality. Things like good naming conventions, sticking to PAP8. These are things that basically don't cost anything. Using one naming style versus another, it takes no extra time, it takes no extra thought, it takes no extra work. But it makes your project just a little more accessible to new developers who come to your project. When you bring someone on, they immediately know what the coding convention is because the community is a standard and they're a part of that. They're already familiar with it. All these things are basically, they're habits. They're not something. One coding convention over another isn't somehow objectively better, but we have a standard as a community, and when our projects embrace that, it makes it more available to members of the community, which is a big advantage. I think the final point is about measurements and analyzing. So I started with the idea of automating all these processes, automating how things run. I think that the final level of this is measurement and analysis is understanding what the project is actually doing. I worked at a place once with the way that we knew errors were happening is developers basically just they they just tailed the log file, and when they noticed it was moving too quickly, that probably meant we were experiencing a lot of errors. So, in addition to this being completely crazy, it meant that the only way you could really know if the project was having trouble is if you'd already been looking at it for 3 months and had a sense of about how fast the log file should be moving. This is like completely crazy. It means new developers basically have no way of knowing if something's broken, except saying, hey, does that look like that's moving too fast to you? Which seems a little nuts to me. So things like useful logging means being able to know sort of what approximately a process is doing, what things are happening. Error analysis. We are extremely lucky as Python developers that this package Sentry exists. Sentry is basically the most awesome thing ever. If you do really anything that can have error reporting in any way. So Sentry is a package that you basically send it your any exceptions that happen, and it will automatically aggregate them by where in the code base they're happening, what the exception string is, and give you really, really great analysis tools, like showing you all the local variables that exist. If you happen to be in the context of a web request, it'll show you what the current request that happened when you got this exception was. It is an awesome analysis tool, and it, in addition to making things really awesome for experienced developers to debug problems, make it much more obvious to a developer who's just learning a project how something works, because they can really easily see, okay, we just got an exception report. Now I can look at this and try to debug. I don't need any special knowledge about what does this message mean. I've got the whole traceback before me. And the final piece of this is measurements, being able to see, okay, how many requests are we having, how many users are hitting this page, how many times is this function being called. And again, as members of the Python community, we have two really, really cool packages. StatsD is like an existing stats daemon for aggregating stuff, and MMStats is a really cool up-and-coming package for doing sort of in-memory sort of aggregation, and it has a lot of cool tools for looking at data and stuff like that. So sort of to recap everything, I think you should automate everything, because automating gives you two huge benefits. It means any developer can do the process, whether it's deploying to your server, creating a new server, or anything like that. And it means that you've got code that says how something works, so any developer can learn how something works just by reading code. I think you should embrace the community, because it means your developers are more familiar with your software. It's one less thing they have to learn, and it's experience they can bring with them to every project they work on. And really try to embrace all of these strategies, most importantly, to make getting started with your project easier. Make it as easy as possible for a developer to write their first patch and test it out. Make it as easy as possible for a developer to get feedback and learn how your systems work. That's all I've got. So thank you guys very much, and any questions?
Are there any questions for Alex? Yes.
Yes, the slides will be available at that URL right there, right when I get back to my laptop.
Hi, just want to know if you have you ever used build-out for deployment and what you think about that.
I have not used build-out. I have heard from people I consider really, really smart that build-out's really, really cool. Unfortunately, I'm not familiar with it enough to give any sort of useful opinion.
More questions?
Yep. So first of all, there's a speaker who I think talks a lot more and a lot better about automated testing than I do. Gary Bernhardt. He is an awesome speaker, and he has a lot of videos about automated testing. I think just to get started, the most important thing is that you start writing tests, whatever they look like, to just start getting into the habit of automating. I've sort of come down on the side of tests should basically test how things are used at whatever the right level is. So some things I test by, okay, let's just send an HTTP request and sort of see what comes back. Other things I like to test by, okay, let's dig down. What is the API of this internally? So let's instantiate an object and let's check that the methods return certain values. I think it's all about understanding how pieces of your project will be used and sort of testing at a layer that gives you flexibility. You don't want your tests to lock you into something. You want tests to free you up to be able to make changes down the road and still understand that your stuff won't break. So I think finding a level to sort of test at the level of this is how this thing will probably be used going forward forever, even if we change how it works, is the sort of the best level. I keep tests with the code. Yeah. Basically, sort of running the tests should be the same as any of the other things I talked about. It should be really automated. You should have good tools for looking at if you have test failures. I'm a huge fan of the py.test library because I think it makes testing so easy. I think one of the downsides people see in testing is, oh, it's going to take us a lot of time. It's a lot of work to get set up testing. And so I think the thing I really love about py.test is it makes testing as easy as it could possibly be.
One thing I noticed is there is, depending on which project you're looking at, there's a disconnect between deployment and development. So the current code base we have, it's very easy for a new developer to get started with because it's basically check out from Git, run the thing, and then you have roughly the same environment as you have on the servers. But now we're adding more and more services, and we add more and more hacks to the code base in order to make the development environment have the same feeling as the live one, but it's just a very different environment. And I don't think like Supervisor D necessarily helps getting the development environment look the same as the live one, because there's just nobody wants to run like Nginx locally when you can just use the Python server. So there's just a difference in there. And one thing we started looking at was Vagrant, but it's like you make a virtual machine locally, which replicates entirely your server environment. But it seems like it slows down the whole process. So how are you handling that in the company?
So first of all, really great question, and I totally agree with the premise that development should be as close to deployment as humanly possible. I also agree that it's really hard, and something like Supervisor D or a virtual env are probably not sufficient. So a classic problem we have is we're a music company. We get music from the record labels, and for obvious reasons, we don't want to keep all of our music available locally, or really even any portion of that. So when we test the system that actually takes the things the labels have given us and actually turns those into rows in our database, it's a process that you can't really run locally very easily. So one side of that is we have automated testing for that sort of mocks out certain portions of it. You know, make sure that these files exist for us in the right place, and we don't have to worry about those actually coming from somewhere on your actual system. I think using something like Vagrant, which is a project that basically lets you automate creating and spinning up virtual machines, is a pretty cool idea, and it obviously gives you the highest level of sort of isolation and automation. You know, each project has its own virtual machine, which is set up exactly how that project works, and you can share the exact same configuration as your production machines because it's just running the same configuration code. For me, the problem the last time I worked with a project on a virtual machine is it just made everything a little bit more inconvenient. If I wanted to do certain tasks, now I had to SSH into the virtual machine instead of just running them locally. I think if someone can solve the problem of sort of to step back, my workflow is I keep basically one terminal window open per thing I'm working on, and then I open up a bunch of tabs within it. If someone could solve the problem of having a terminal that just sort of followed that it was on SSH when I opened up a new tab, I think that would really lessen sort of the inconvenience of having to work with a virtual machine. And that might be a step towards using a virtual machine and having this highest level of isolation more accessible. Because I think a huge part of this is everything that can reasonably be possible to be convenient ought to be convenient. When things aren't convenient, that means that they have too many steps, steps are too slow, and it just means that there's the more steps a process has, the more an individual needs to know to perform those steps. And I feel like if running this process is step one is start up the virtual machine and go to the right place, all these are extra steps that just make it a little less accessible. So I guess I don't really have a good answer besides if it can be automated, if you can test it in an automated way to sort of set up the environment there. That's I think a good middle ground for testing a lot in terms of getting a lot of systems up and running. Otherwise, I don't have very good answers, unfortunately.
Any other questions? No one. Right.
Oh, one more.
Oh.
Yeah, okay, so it sounds like a combination of build out and supervisor D is a really good combo. Yeah.
Cool. Alex, thank you very much.
Thank you
Appreciate
guys.
it.